So today I will be talking about my take on improving epilepsy. And so before I begin my presentation, I would like to tell a few things about myself. And so as you know, my name is Azeez Abdul. I live with my parents in Dallas, Texas, and I also live with my twin brother, Azeez Abdul, who has epilepsy, and he's a really big inspiration for me. And so before I begin, I also want to thank Science First Society for giving me the opportunity to present here today. So today I'll be talking about epilepsy and the device that I created to reduce the risk of shock to patients who have epilepsy and who receive the external trigeminal nerve stimulation treatment. So what is epilepsy? Epilepsy is a neurological condition caused by many different factors, ranging from genetics to birth complications to brain injury, and the reasons for it can also be unknown. And epilepsy is associated with seizures. A seizure can occur when there is rapid electric activity in the brain cells, and the seizure discontinues after a few seconds or even a few minutes. And this results in convulsive movements of the limbs and excessive saliva, which is important because my device addresses these issues. So as you can see here, there's a diagram of the brain and the brain cell, which includes higher levels of electricity. Current treatment options include medications which increase or decrease levels of chemicals and neurotransmitters in the brain. And for patients with moderate to severe epilepsy, there's the vagus nerve stimulation option, which is sort of like a pacemaker for the brain. So just like a pacemaker for the heart regulates rhythms of the heart, the pacemaker of the brain regulates electric activity in the brain. And so this sends electric stimulation to the vagus nerve, which goes up to the brain, and results have shown that this is effective in treating seizures. As a non-invasive option, researchers at UCLA developed the external trigeminal nerve stimulation device, which is seen on the right, which is completely non-invasive, and it is a electric patch on the forehead. As I said before, it was developed in 2008 at UCLA, and this sends electric modulation to the brain. And so it stimulates the brain and a specific nerve called the trigeminal nerve, like I said before. And this has been proven to be effective for seizures, depression, ADHD, and other such neurological conditions. And before I move on, I want to show a quick video.
Nerve stimulation device uses mild electrical impulses to treat seizures. Clinical trials indicate the device may help treat depression and other mental illnesses. The device consists of a cell phone-sized battery pack that can be strapped to the waist. The battery is connected by 2 wires to an electric patch worn on the forehead. The patient wears the device for 8 hours while sleeping. The electrodes in the patch send small electrical impulses that stimulate the trigeminal nerve in the cranium, boosting blood flow in areas of the brain that affect seizures, mood, and concentration. Neurosigma's.
And so, while I was researching for my science fair project about different treatment options for epilepsy, this treatment really stood out to me because it has lesser side effects and it is non-invasive, meaning it's completely outside the body. So, but also while researching, I came across some risks that were associated with this treatment, such as the potential risk of shock to patients who receive this treatment. So what can happen is, while the patient uses this device while sleeping, like the video said, when a seizure occurs, there's excessive saliva. And this excessive saliva can interfere with the electric impulses that are sent to the brain. And over time, this can lead to health complications and is a severe risk as well. And so I created my device, external trigeminal nerve stimulation shield, to address this risk. So before I move on, I want to give a little quick timeline of how I researched and built this device. And so I had about 7 months to build this device, all the way from August to February. And so from August to about November, when the school fair was, I researched, built, and tested my device. I researched many publications, articles, and other such things. And there was a couple months between the school fair and the district fair, in which I received feedback from the judges about what I did well so I could continue to do it, and what needed more improvement. And so between these different fairs, I went back to my project, I learned some new things, I built some new things, and I tested some more. And so as you can see the quote, learn, build, test, move forward. This was what I basically did throughout these 7 months. And so here's an actual picture of my device. So as you can see here, it is made out of acrylic and carbon fiber vinyl and suction cups, which I'll explain more in the upcoming slides. So before I begin the entire building process, I went through the prototyping process, in which I built 3 main prototypes, and I made small changes between each prototype. And I used a computer-aided design to make those changes. And as you can see here, as like the code says, that small changes lead to big differences. And so each day I would go and I would log in and I would make some new small changes, which overall would lead to big differences, like you see in the picture. And so as you can see here, I built my device out of acrylic, I chose acrylic because it was shatterproof and it was lightweight, because I wanted it to be lightweight because the patient wears this, so you wouldn't want something that would be too heavy. And to connect all the pieces together, I used polyurethane, which is sort of like epoxy, and it has a really good strength. And as you can see here, the small pieces that I have here were the tunnels and channels that I created to trap that excess of saliva. And the whole building process took me about, like I said, the entire process took me 7 months, but the building process took me about 4 to 5 months, with major building during Thanksgiving break. And so, like I said before, when I went to the school fair, the judges, they gave us feedback on what we could do better and what needed and what was good. And so when I began all of this, I researched articles and publications done by researchers, neurologists, and people who were generally in that field. And from there, I gained some ideas on what problems in the epilepsy world were needed to be addressed. And so I've included a quote by Albert Abdul, who is a biochemist, and he said that research is to see what everybody else has seen and to think what nobody else has thought. And so throughout this process, that quote really stood out to me, because you can look at the same thing, but different people have different perspectives. And with my perspective, I did this project. And I also learned a lot of skills with this, such as logging skills, because each day when I worked on this project, I had to log what I did and how outcomes were. As you can see, I've made more modifications for the district fair and the regional fair. And so I wanted to make my device effective. I just didn't want it, I wanted it to work but be very effective at it. And so I included another testing method for my regional fair, in which results proved that the device is working better than initially thought. So also I've included a new design for the ETNS patch, which is compatible with my device that I built. So like in the video, you saw the patch that the model was wearing, and this is the patch that I recreated. And so in my results, my results showed that the device was very effective, because none of these saliva was ending up on the patient's forehead. Most of it, all of it was ending up in my device, which was what I planned on. And so, while doing any project, there can be errors, and I had many errors that I went back and I fixed, and like the sizing, the placement, and the different aspects of the device, such as I wanted to improve the strength, I want to improve the effectiveness, like I said before. And so every day, I would go back and just make these changes. And also, what was interesting for me is that science fair, it really teaches you to learn new skills, such as coding. And coding, I learned, I had no prior experience, but through this project, I learned a new skill, which was really effective for this project and for upcoming projects that I did. And so I don't want my project to stop here. I want to continue my project and to continue to modify my project for other similar treatments like the ETNS system. I want to take my project a step further into the biomedical engineering field, which is currently very, developing, and a lot of new outcomes are happening every day. And so, moving on. And so, my inspiration definitely has been my twin brother, and seeing him grow up, with all the treatments and the side effects of those treatments has really inspired me to look for answers in the epilepsy community. And some of those treatments have drastically affected his life, which has in turn affected my life to pursue research answers in this field. And so, the quote here is to turn your challenges into opportunities. And definitely, I've tried to turn my challenges into opportunities. And from a young age, I have done that. And when I was actually in the 3rd grade, I founded the sibling support group, the special needs sibling support group for siblings like me who have a brother or sister with special needs. And so I did it because I wanted to let other siblings like me, that they're not alone, that they have someone to connect to, and for someone to share their experiences with. And so, and also, throughout my entire life, growing up with my brother, and I've tried to, I've written different articles and different posts about, my experiences, and I've done different projects regarding that, and I've learned different skills with him as well, such as by the age of 10, I learned how to do seizure first aid, and this is something that all of us can learn and should learn because, in the general public, the stats show that about 65 million people across the globe have epilepsy, and here in the United States alone, 1 in 26 people have epilepsy. So there's definitely a need to learn seizure first aid because the people around you, to be useful for you and the people around you. And I want to encourage myself and other students to search for options for chronic illnesses like epilepsy, and because there's something that it can make a difference in someone's life. My parents have always taught me to not do a profession or anything just for money or just for recognition, but to do it to make a difference in someone's life. And so recognition. There's some recognition that I've received for this project, like winning at the Dallas Regional Science and Engineering Fair. And so recognition like this has motivated me to continue to research in this field. And as you can see in the next slide, some of the recognition that I have received, at the district and at the school fair, and those are all the names, some of the names that were published there. And science fair is a really interesting experience because you get to meet different people with different thought processes, with different perspectives on the same idea sometimes. They may be tackling the same issue, but those different perspectives really help each other find answers for some of the problems that we are facing. And as you see in the next slide here, this is the actual board that I took with me to the fair. And this is not my first board, this is actually my 3rd board. And so, coming back from each fair, making more changes to the device and my board as well. And so, as you can see, I went into way more detail in that board about my goals for this project, and much more details into the actual results as well. So here are a few more ribbons that I have received and I'm very grateful for. And next, here are some pictures that, of me going to the fair and me actually at the fair. And so the fair, like I said before, you meet different people, and it's a very big, event which can inspire students to really, continue looking for answers. And so a few months ago, what happened was the Babu Gogineni Facebook group and Indian Humanists, they organized a artwork competition, which was to sort of which was sort of about the superstitions and myths which were present in society. And so the artwork that I chose to do was a school-going child who is saying, "Hey there," to a couple of bystanders who are pointing fingers at, a person who has a disability and is in a wheelchair. And they're saying that this person has that disability because he's committed some sort of sin in his past life. And this school-going child, he's rationalizing, and he's saying that, that this disability isn't something that you've done in your past life, and that this disability has occurred because of a medical reason, and that this is the only one. And so this is some of the ways that I've done to just spread awareness about disability rights and disabilities in general, and especially epilepsy. And here are a few recognition that I've received for that artwork, and I'm very grateful for that. And thank you.